Why don't you guys try 3 and 4? Try those two first. All right, friends, I want to check in. I want to check in on what your U would be for number 3. So if you don't mind, why don't you type your U into the chat box and I'll count it down. Ready? So we have U equal to number 3. Ready? 1, 2, 3, go. I have 3 people answering. The good news is those 3 people are correct. So if U was your 3t, du dt is equal to 3. This tells you that dt is equal to 1 over 3 du. So you get the antiderivative of sine of secant of u tangent of u times 1/3 du. And you can pull out the 1/3. Is there any questions about this so far?
Professor,
Yes.
like I don't know when should I pull out like the something from the like the 1/3. When can we know we should pull it out?
If it's a constant, so a constant times your integral, you can always factor it out. Let me show you. See how we have these properties of the integral? Number 5. Anytime you have a constant times your function, you can pull the constant out. Does that make sense?
Yeah. Thank you.
Okay, no problem. So I want to make a comment here. Some of you don't know that the antiderivative of secant u tangent u is secant u. Like you don't know your trig antiderivatives. So you're going to try something crazy like u equal to secant 3t or u equal to tangent 3t. That's why I said integration is harder than taking a derivative. Like you have to have some sort of feel for where it's going to go before you kind of make your substitution. You need to recognize the antiderivative of secant sitting right there. The problem is the 3t. You really wish it was just a single variable. So that's why you make that be u. So this is 1/3 secant of u plus c, which is 1/3 secant of 3t plus c. Is there any questions about number 3? Okay, try number 4. Let's just think about it for a little bit. So the first comment I want to make is if you let u be equal to theta, du d theta is equal to 1, d theta is equal to du. So your integral becomes the integral of secant squared u tangent cubed u du. This is literally the same problem. You just call the variable a different name. So that's not a good choice. You're just renaming everything a different letter, but that doesn't make the problem any easier to solve. So I don't think we should do that for sure. A lot of students do that as well. So Leah, having u be equal to tangent squared theta when you take the derivative of this, you're going to need to use the chain rule. Actually, that might work in this case, but it's highly unusual. So yeah, I don't even want to go there, actually. Actually, your guess might work, but I think the most straightforward guess would be to have u be equal to tangent theta. And how do I know that that's really a good guess? Well, for one thing, this tangent cubed is going to be something simple to integrate, like u cubed. But even more importantly, I see the derivative of tangent sitting off to the side here. That is an immediate clue. I made a good choice for what u should be. So let's just finish this off. I got du d theta is equal to secant squared theta. This means du is equal to secant squared theta d theta, which tells me d theta is equal to 1 over secant squared theta du. So when I make my substitution, I'm going to get the integral of secant squared theta. I pray that cancels out. U cubed, and then 1 over secant squared theta du. And these guys here cancel each other out. Your integral becomes u cubed du. I want to warn you guys one more time. Sometimes students are so happy they get the right substitution, they forget to actually integrate. Like you have to integrate after you make the substitution. The technique is called integration using substitution, not just making substitution. So this will be u to the 4th over 4 plus c. And then your final answer would be tangent to the 4th theta over 4 plus c. Does that make sense? Is there any questions? All right. Let's finish things off with number 6. Try number 6. No, you guys are correct. Pi over 2t. So I hope that you guys are changing the limits of integration. So you've got x equal to 1, that has to go to u equal to something. X equal to 0, that has to go to u equal to something. So I want to give you 2 more minutes to finish this off before I go over this myself. But I just want to make sure that you're on the right track. So just try to finish this off. All right, folks. Let's change these limits of integration. So when x is equal to 1, u is going to be equal to pi over 2 times 1, which is just pi over 2. When x is equal to 0, u is equal to pi over 2 times 0, which is 0. I need to calculate my du dt. So my du dt is equal to pi over 2. And this means my du is equal to pi over 2 dt, which means my dt is equal to 2 over pi du. So my integral is going to go from 0 to pi over 2 now. I have cosine of u, and then my dt gets replaced with 2 over pi du. This is just a constant times your integral. So you can factor out the 2 over pi. And you're going to get from 0 to pi over 2 cosine of u du. The antiderivative of cosine is sine. U from 0 to pi over 2. We do not switch back to x. So this gives us 2 over pi sine of pi over 2 minus 2 over pi sine of 0. Sine of pi over 2 is 1. So that's going to be 2 over pi. And sine of 0 is 0. So your answer is just 2 over pi. All right. All right, everybody.